Okay, so using the values we found here for our betas, we've stored them into our matrix C. And now we can do a calculation to find the standard error, which measures the accuracy of our predictions. And in order to do this, we first need to find our error term. So the error term is equal to the y values minus the estimates you get for y for subbing in certain x values. So the estimates are denoted as y hat. So if we multiply our x matrix, or matrix A, by our beta coefficients, which are matrix C, we'll get our values for the y hat, or the estimates. And I stored these into our next matrix, which is matrix D. In order to find the error term, you have to do y minus y hat. So we have both of these already stored. Our y values are in our matrix B, and then our estimates, or y hat values, are in our matrix D. And so this will give you a new matrix, and you'll store that in the next one, which is matrix E. And the next thing you'll need to do to find your standard error will be to calculate this formula. So you have S sub E squared equals E, which is our error term, transpose the error term, divided by n minus k minus 1. N is the number of observations you have. So in our case, we have 5 observations. K is the number of independent variables you have. So we have x1 and x2, so that would be k equals 2. And then minus 1, which is just standard. This will give you a value, just one value, so no more matrix outputs. And you'll be multiplying that value by the quantity x transpose x inverse. If you hit enter, which I'll show you in a bit, you'll get a variance-covariance matrix. In this variance-covariance matrix, you'll be getting values here and here. The only ones you're caring about are your diagonal values. So your diagonal values are the variances of beta naught, your constant, your variance of x1, and your variance of x2, or beta 1, beta 2. And in order to get the standard error for each of these, you're just going to take the square root of each of those values. And that will get you your standard error. So using our calculator to demonstrate this, as I showed you, the first step is to calculate y hat. So y hat is our x matrix multiplied by our beta. So we go second matrix, x times our beta values, which are C, so we hit enter. These are the y hat values, so we'll go ahead and store those in matrix D. And then, as I mentioned, our error term is equal to y minus y hat. So we can go back and hit matrix. We want our y matrix, matrix B, minus y hat, which I just stored in matrix D. So y minus y hat is our error term. And we'll store this, again, in the next available matrix, which is matrix E, and hit enter. And so finding the standard error squared formula, you have in the numerator E transpose E, and the numerator is E transpose E, so you go to your matrix E transpose E, hit enter, and you'll be dividing this value, which you'll have to retype because it enters it as a, even though it's just one value, it's still in a matrix. So you go 30073.728331 divided by n, which is 5, minus k, which is 2, minus 1. and that gives you a value which you'll then use to multiply by x transpose x inverse. And now we have the variance-covariance matrix that I talked about. And as I mentioned, it's a huge matrix, but you're only caring about your diagonal values. So this, you'll take the square root of to get your standard error for beta naught. If you scroll over this middle value, you'll take the square root of to get your standard error for beta 1. And take the square root of this value to get your standard error for beta 2. And that's all.